Hi, this is my Piet simulator, an intuitive Piet interpreter with Visual Debugger, a .NET 10 application. Piet is that insane language where code is just colored blocks in an image. Why I built this is I saw this crazy language and I thought I want to try it out. I found some online editor and runners but couldn't figure out why my program looped forever or doing random things. The tutorials are rare. Although the npit has a debugger. Something like this. But I want a simple real-time visualization to see exactly where I messed up. Thus, this tool you can run step by step or auto run. It's not the prettiest, but it just works. It shows the operation, the stack change in image and the panel, the current position and visited blocks. So for this application, it will print hello world, then the program will halt after hit the barrier for 8 times, and all the detail of each action will be printed to the console. Here's how to use it. First, we can find an image from this website and use a small one. This is the real size image and it's a PNG file. So my application can support PPM and PNG, JPG, BMP. For PPM is a text-based definition of image pixels. So this is the width and height and maximum color. If you just read this as integers, this is created with the npit edit tool, but for now I will just go for the image. So first I need to copy this image path to the npit file path define, and in here I'll paste it. Okay, I'll just paste it, and these lines with hashtag will treat it as comment, and you will find the first path which is not a comment and run this file. So when I click this, it will load this image file and it will show the current position and the grid. This is the current block it will execute. So if I make a step, I can know that there was 72 blocks in this red area, and when color changes it triggers a push. So this is try to make it simplified, because if it's too long it's hard to display in this block here. So I just keep running it and it will print a hello world. So this is another version of hello world, and the way it works is quite simple. So this is kind of a part of my code. So the way it chooses where to go is simply by choosing with a direction pointer and codo chooser. The current direction pointer will be right side and the codo chooser is left side, so we'll find the most right block, which is this one. And if there's an edge, like there's a multiple blocks in the rightest side, it will find the left according to the direction, so the most leftmost. So this will be the block, and it will start from this block and move to the direction of the direction pointer, so which is moved towards the right side. this right is kind of the global direction, and this code truther is the relative left or right according to this direction pointer. So let's run some more. So when you reach here, it will try to go to the right side, but it found barrier. It will roll back to see if there's another way to get out. Direction pointer becomes down, so it will try to go down instead of going right. Code truther is the right side, so it will find the actual left side because it's the right side from this pointer. Then it will step. So in here, it will step again. So this is the way it chooses the right side of this pointer. So it will pass this side instead of the other side. How this program works is push this 72 into the stack and pop up the stack and print it to the console. So I'll just demonstrate how this works for the rest of the part. So the way it moves, it got blocked by this black box. Then it enters this trap. So this is how you stop a program. So it will print and it will try to find a way out. But with something like this, a T, and these black blocks will stop the program. And for Piet, it does accept user input. So I'll try another program which is power 2. So this will calculate the power with 2 numbers. Okay, so just close this and run this program. So for here, this will trigger input number in, and I will have to type a number such as 12, and to ask me to input another number, let's say 2. So it will try to calculate 12 squared. So when I press enter, it will calculate through this program. Just make it faster. And the result is 144. And that was about my interpreter. But now I'm gonna talk about something I know about this language and how to make your own program. I don't know much about it because I'm new to this. So first, I found this website page through Google, and I can see here's external resources. You can find in Piet editor and download this. For me, it's Windows, so I'll just download this. And I got this zip file here. I can just put them in anywhere. So I'll just create a folder, demo, and I extract these files into a folder. And in here, there's a README. With this README, you can see we need this TK-TCL to run this edit. So I have installed TK-TCL. I'm not gonna cover this. You can try to Google it. Then with the terminal, with the TK-TCL, I can use wish and to run this editor. It's a relative direct from this directory. Okay. So it will run this file, and this is the editor. So let's make something simple as print out a 9 Okay, I'll just color 9 blocks. You can start from any random color you like. You can use this cyan and make a push. I need to push this into the stack and pop out the stack and print out the result. So this is equivalent to this. So they are the same thing. It's just different color in the beginning. So when I save this, it will create npit edit filename.ppm, and this is the file of the colors. Then to run this file again with npit.exe, run this, and we'll print 9 as like 2 of this is just print out 9. And with the rule, I can make something like a stop, something like this, the T. I need the T. Okay, so I'll use the same color as the last one and put it here. So save this and run it again. So it will print 9, 9. If I remove one of this, it will print a 9. Somehow my program didn't stop. So I think it's because it can go all the way up. So maybe by doing this, I can prevent it from going to the top. So save this. Okay, so this is how it runs, and with the same way I can use my program to see how it works. Okay, in here, step, 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 and you end after printing a 9. So the reason for this to be keep looping will be demonstrated here. So it tried to find a way out, it failed, it go up and back down again. So this is the reason for it to be in an infinite loop, and it will not remember the last color it came from. So this can be any color. For example, I can replace this as this new color here. I will run the same thing. So only in here, from a colored block to another color block will trigger a command. Otherwise, if it's a white, from either from white or towards the white, will not trigger anything, and previous color will not affect it. And to create this program, in here it's kind of just choose a pixel relative to this 6x3 box. So these are all the instructions, operations you can use. So if I want to add 2 numbers, clear this and put this back. Okay, so here I can make a program, start from a number 6, and I want to add these numbers together, but I'll have to push them into stack first, because when you're using add, subtract, and this, you need the numbers to be in stack. So I can do a push, and this first one will push a 6, but this is another number. It will be treated as another number, so I can push this number again. So this is red, and if I do push, it will be dark red. So this only need 1, and after pushing the 2 number into stack, I can add the numbers which are in the stack. It will pop out the top two numbers and add them together. Then I can print the number, print the result. So in here, I can run this program. Step is 6, 4, add, and print. So it will print 6 plus 4. The pointer. So the pointer will change the direction of the pointer by rolling it, by turning it clockwise for n times. So for example, if I want to turn this pointer once, I can use push this one here. So this will push a 1 into the stack, and I can use pointer, so it will turn 1 time around, so right side to the downside, and it will keep moving down instead of going right. So push 1 and move down, so it will keep doing this. So the first time it got to here, 2, 3, and blah 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 blah. Okay. And for the chooser, here's a switch. The switch will turn the Kodo chooser. In here, it's defined as this, from like switch between left and right. This is 3, push, print. Oh, print. So this should print a 3. And the Kodo chooser is on the left side, so it will find the leftmost from this block. But if I use this switch here, okay, so need to use this as a relative. If I switch it, then print, it will try to use the exit from here instead of here. So I can put another number. So in here is like push. Or print. So if it goes to here, if it goes through the upside, it will push this 3 into the stack and print the number. But if it goes down, it will just print the result. So I have to add more of this. Print. Oops. Okay. So this will be a switch. So from here, with a switch, the coder chooser turn from left to the right, and it will find the edge and find the rightmost exit from this direction, and it will print the result, which is nothing here. The number of the stack as the times it switches. So if I use a 2, let's say if I take one of this away and I like it to switch twice, it will go right and left, so it will not affect the result. So if it's odd time, it will switch to the other side. If it's even time, it will maintain the same. Greater, it pop A from stack, pop B from stack, and get the result either 1 or 0 if it B is greater than A. Yep, so with this rule, 6, push, and push, and find greater here and output the number. Okay, so this should be 0. The second one is on the top of the stack, I think. This is the second number because it popped from the top, and this will be the second last from the stack. So they have a reverse order of calculation, and that's why it's like 0 and 1 here. This will be 1. Okay. Row. Okay, row. I had hard time with this when I code my my coding. I have to use a do row as it just gives me headache. So the way it works is it rotates the stack with given depths and the time. It will take a row and depth. So let's see, I need to push more number here. This is what the current stack look like. So when I do row, I can choose the depth and roll this depth multiple times. For example, if I want to rotate this 14, 8, 5 one time, so I can push a number into the stack. So this is the depth. The depth will be 3. Okay, and I need to push the depth in and rotate it one time. So I will push 1 here. Depth 3, push, rotate one time, push. So the stack will have 3 and 1 on the top, like this. 3 and 1. So it will rotate this 3 number one time. Now let's do a rotate. Okay, so it will use these numbers as arguments. So you can see the 8, 5, 14 has been rotated. So previously it's a 14, 8, 5, 6. Now it's 8, 5, 14, 6. So this got rotated once. So the toppest become the lowest, and the other ones just move forward. So if I push a 2 here instead of 1, it will rotate twice. So in here it's 14, and it moved once, twice, so it landed here, and the other ones too. So the 5 will move forward and forward, taking 14's place, and so on goes for the others. The input number will accept the input as a number, and input char will allow you to input a character and use the ASCII code as an input. So for example, I'll just remove this, make a new one. Okay, this will clear everything. Character, it can be any size. Okay, this is the first one, and input a character. Okay, then I can print out the number of this character, so it will show you the ASCII code of your input. For example, if I want to use A, it will show 97 here, and it will print out 97. So this is a simple program that can output the ASCII of your input char. And for duplicate, it's just calculate, it will take the previous stack. So push 9 here. If I do duplicate, it will copy this and push it into the stack again. So step, there's a 9 in the stack, and duplicate, you have 2 9s here. So with all this, it is possible to create some awesome programs which is so interesting. So this is the factorial. You can use this to calculate the factorial of a number. Again, find my file here, and I will put this aside, then run my program. Okay, so at the beginning it will require you to input number. I'll say the factorial of 4. So we'll get 4 times 3 times 2 times 1 is 24. For this, now we can understand how it works. That's the end of the video. Thank you for watching.